Okay, students, welcome to the session. We were discussing the various methods to find out the integrals of the various kinds of functions. So, in this connection, we have discussed a number of methods which will help us to find out the integrals of the various kinds of functions. Now, in continuation, we will discuss a new method which is known as method of integration by partial fraction. This will also help you to find out the integrals of the various kinds of functions. Actually, this method, integration by partial fraction, is considered as the biggest tool to find out the integrals of the various kinds of function. What is the basic requirement, basic prerequisite for utility or for application of this method? The function should be of the type of fx upon gx, right? It means if your function contains a numerator as well as denominator, only then we can use the method of partial fraction. Otherwise, we cannot use the method of partial fraction. However, at most, fx can be equals to 1, right? So naturally, if fx is equals to 1, then the function will become 1 upon gx and then dx. Even then, in this case, we can use the method of partial fraction. So you know about the proper fraction and improper fraction. If the degree of the numerator is less than the degree of the denominator, then the fraction is called the proper. And if the degree of numerator is greater than the degree of denominator, then the fraction is called improper. And you should keep in mind one of the very important point when we have discussed in the very beginning. Whenever you are having a function of the type of numerator upon denominator, then we can integrate the function only if the degree of the numerator is less than degree of the denominator. Otherwise, we cannot integrate it. However, if the degree of the numerator is greater or equals to the degree of the denominator, then what we did? We divide numerator by denominator to reduce its degree as compared to the degree of the denominator. Then we will find out its integral, right? In fact, the improper function is improper rational function is being transferred to the proper rational function by dividing numerator by denominator, and then we can integrate the function. Let us take the method. Actually, what happens? See, before proceeding this method, let me discuss the basic concept of this method. How does it work? Our function is of the type of fx upon gx, right? This is the function whose partial fraction we want to determine. So before proceeding the solution or the method, what is the meaning of the partial fraction? Partial fraction simply refers if you have a big object, you will have to decompose this big object into its smaller parts, right? So partial fraction simply refers to the disintegration of an object into its smaller parts. So what we will do to find out the integral of a big part, what we will do, the parts in which this has been disintegrated, we will integrate each part and sum up the sum of all these integrals will give you the integral of the required bigger part. So partial fraction simply refers to the decomposition of a big function into their smaller parts. And then we will integrate each of the smaller parts to get the required integral. Right? So what happens here, the basic idea for this method is what? Fx upon gx, the function must be of this type. Fx is called numerator and gx is called denominator. So the partial fraction completely depend upon our denominator. So what we will do, we will find out the factors of the denominator. I have discussed this term factor many times in the last few lectures. Factors method you must know. You all have studied to find out the factors of the various equations at your earlier classes. So I cannot explain the method of finding out the factors of any equation. So what we will do, we will find out the factors of our denominator. So whatever denominator is given to you, equate it to 0. Now this will be treated as an equation. So naturally, if this is an equation, then we will find out its factors. So when you will find out its factors, what would happen? The factors may be linear, right? And the factors may be quadratic. Linear means the factor is said to be linear if the power of the variable is 1. A factor is called quadratic if the power of the variable is 2. Now, further, if the factors are linear, then the linear factor can further classified in two categories. For example, there are two factors of a quadratic equation and both the factors are linear, but both the factors may be distinct or both the factors may be repeated or same. So this can be further classified as linear means the factors may be distinct or they may be repeated, right? First, we will consider the linear case, then we will discuss the quadratic case. Likewise, in case of quadratic, we will have the two possibilities, distinct and then repeated. Repeated means a factor is being repeated once or more than once. So total, we will get four possibilities, right? The factors of the denominator may be linear and distinct, case 1. The factors of the denominator may be linear and repeated. Repeated means same, case 2. Case 3, the factors of the denominator are quadratic and distinct. And case 4, the factors of the denominator are quadratic and repeated. So total number of possibilities in this method of partial fraction are completely 4, and we will discuss, I will try to solve the questions of each. So these 4 possibilities will be discussed in separately, right? Now let us consider the case 1. When the denominator contains non-repeated linear factors. This means what? When the denominator of the given function gx, its factors are linear, but both the factors are distinct, right? Case 1, if the factors are linear and distinct. And then see what happens. What we will do, the process of finding out the partial fraction of such functions is what? You know, the linear factor is written like this, ax plus b, right? A and b are any two constants. I have taken here p1x plus q. So take the same form, p1x plus q, right? p1 and q1 are the constants and x is a variable. See, the power of a variable x is 1. Therefore, this is a linear factor. So if the factors are linear and distinct, then what we will do, for each linear factor, we need a single constant. It means how many factors the denominator will have, we will need to introduce the same number of constants. For example, if denominator contains 2 factors and both the factors are linear and distinct, then we need one constant for each factor. A constant upon first factor plus any other constant upon second factor. This is how we will start our process of partial fraction, right? Let us understand this concept, and then finally we will find out the values of the constants a1, a2, a3. Here we have what we have written. See, gx is having 3 factors, p1x plus q1, p2x plus q2, p3x plus q3. What does it mean? It means the denominator gx is having 3 factors. And all these 3 factors are linear and distinct. So we will write our expression as a1 upon the first factor plus a2 upon second factor plus a3 upon third factor. This is the partial fraction of the given function fx upon gx. And finally, we will have to find out the values of a1, a2, a3. So a number of methods are available to find out the values of A1, A2, A3. You can choose any one of the method of your own convenience. But I will discuss before you is the simplest way out so that everybody can easily understand the process to find out the integral using the method of partial fraction. Let us take an example. Evaluate this function x upon x plus 1 into 2x plus 1. See here numerator is x and denominator is x plus 1 and 2x plus 1. Denominator is already in factored form. If it is not in factored form, first you will have to find out the factors, right? Be careful. It contains two factors. One is x plus 1 and other is 2x plus 1. So what we will do, one constant for this linear factor and other constant for this linear factor. So see, let x upon x plus 1 into 2x plus 1. This is our function. A upon first factor plus b upon second factor. If there would have been third factor, then plus c upon third factor. If the fourth, then d upon fourth factor. The number of constants are always equals to number of factors. And now what is left? Find out the values of the constants a and b. So this equation is in fact known as the partial fraction of the function after getting the values of the constants a and b. So what we did actually, this single function has been decomposed into sum of its two smaller parts. And this process is known as the partial fraction. Now find out the value of a and b. And to find out the value of a and b, what we did, see, the approach is what, take the LCM both sides, right? This is the only way out and the simplest way out. In the left hand side, what we have, x upon x plus 1 and 2x plus 1. This is our left hand side. This is equals to what? At the right hand side, take the LCM. LCM will be x plus 1 and 2x plus 1. Now see, x plus 1 will cancel out with x plus 1. What you will get with a will be multiplied with 2x plus 1, right? And 2x plus 1 will cancel out with this 2x plus 1 plus b will be multiplied with x plus 1. So this will cancel out with this. What is left? X is equals to a 2x plus 1 plus b x plus 1. So take this as equation number 1. So this is our equation we obtained. Now find out the constants a and b. Since both the factors are linear, you know, if x plus 1 is a factor, then x plus 1 is equals to 0. It means x is equals to minus 1. And 2x plus 1 is a factor. It means 2x plus 1 is equals to 0. So x is equals to minus 1 upon 2. So x plus 1 is a factor, but x is equals to minus 1 is a root. Likewise, 2x plus 1 is a factor and 2x plus 1 is a root. So what we will do, we will put x is equals to minus 1 in this equation number 1. We will get one constant. Then we will put x is equals to minus 1 upon 2 in equation number 1. We will get other constant. So see here, by putting x is equals to minus 1 and minus 1 upon 2 successively in equation 1, we will get, see, put x is equals to 1. What will happen? Let me explain. 1 is equals to a. 2 into 1. X is 1 plus 1. Plus, sorry, x is equals to minus 1. Put x is equals to minus 1. What will happen? X is equals to minus 1 means this is minus 1. And what you will get here? A. 2 into minus 1 plus 1 plus b minus 1 plus 1. So minus 1 plus 1, this is 0. So minus 1 is equals to minus 2 plus 1. What you will get? Minus a. So this implies a is equals to 1, right? So putting x is equals to minus 1, you will get a constant a. Likewise, put x is equals to minus 1 upon 2 in equation number 1, you will get the other constant, that is b. B is equals to minus 1. Now finally, put the values of a and b in our equation number 1. See what we will get. X upon x plus 1 divided by 2x plus 1. This is equals to 1 upon a is 1. 1 upon x plus 1 minus 1 upon 2x plus 1. So this equation is completely determine or defines the partial fraction of the given function. And finally, we have to integrate it. So the integral of the left hand side is exactly equals to integral of the right hand side, first part, plus integral of the right hand side minus integral of right hand side, second part. See, integral of this is equals to integral of 1 upon x plus 1 minus 1 upon 2x plus 1, and integral of 1 upon x plus 1 is what? Log x plus 1, and integral of 1 upon 2x plus 1 is 1 upon 2 log 2x plus 1 plus a constant c is there. So this is how we can find out the integral of any function which is of the type of fx upon gx using the method of partial fraction in case 1 if the factors of the denominator are linear and distinct. Likewise case this, you should do this yourself. I will leave you for as an exercise because I don't have available time to explain all these things. See here, x square minus x minus 2 divided by 1 minus x square dx. So see, the first condition is what? Here the power of numerator is 3 and the power of denominator is 2. So what we will do? This integral is not possible. We will have to divide numerator by denominator. And when you will divide numerator by denominator, you will get this form. See, x cube minus x minus 2, if you divide it by 1 minus x square. So what should be the quotient? We are having here minus, the minus should be here, minus x. X into minus x is minus x and minus x square is x cube, right? Change the sign, minus plus, this cancels, what is left? Minus 2. So you know what happens if 5 is divided by 2. If you divide 5 by 2, what is left? 2 to the 4, that is 1. So this can be written as 2 plus 1 upon 2, means quotient plus remainder upon 2. So this can be written as minus x minus 2 upon 1 minus x square. See this, and change the sign. This can be written as minus x plus 2 upon x square minus 1. We have taken x square common from denominator. So this function has been transformed to this one. Minus x you can very easily integrate. You have to find out the partial fraction of 2 upon x square minus 1. See, 2 upon x square minus 1 means x square minus 1 by using the formula of a plus b, a minus b. This is x minus 1 and x plus 1. Both factors are linear and distinct. So we need a constant for each. A upon x plus 1 plus b upon x minus 1. In the same way as we did in the last example, x plus 1 is a factor. So x plus 1 is equals to 0. So x is minus 1 is the root. So put x is equals to 1 and minus 1 in equation this, and then simplify it. You will get this is as a partial fraction, and then you can integrate it by using the known methods of the integration as we have already discussed. This is somehow different case. Let us take this one. Dx divided by 1 plus 3 e raised to the power x plus 2 e raised to the power 2x, right? So here the numerator is 1, but the denominator is in exponential form. So we should transform. We cannot find out the factors of this equation. To find out the factors, the function should be of the type of algebraic or in the form of an equation. So we will transform this denominator, which is given in exponential form, into the equation or algebraic form by doing what? Let t is equals to e raised to the power x. Listen, see carefully. Then dt over dx is what? It will remain the same, right? No change. And then what is the value of dx? See, what is the value of dx? Dx will be equals to dt upon, dx is dt upon ex, right? And what is ex? dt upon ex, we have taken t. So see this carefully, and then you will understand the process of finding out the integral. What we have taken? We have taken t is equals to e raised to the power x. So see, 1 plus 3 e raised to the power x plus 2 e raised to the power 2x. This will what? 1 plus, we have taken this as t, so 3t plus 2. E power 2t means what? E power 2x means what? E power x and its power 2. So what you will get? It is t square. This is 2t square. Now by this substitution, the denominator has been converted to 1 plus 3t plus 2t square. What is left? Dx. And the value of dx is dt upon 2. Now substitute all these things. So dx upon this. See, its value is 1 plus 3t plus 2t square. This one. And dx is dt upon t. So we are getting dt upon t, t plus 1 and 2t plus 1. Now look at the denominator. It contains three factors: t, t plus 1, 2t plus 1. X has been changed in t, right? The power of t is 1. Therefore, all these three factors are distinct and linear. Now, there are three factors, so you need to have three constants. Use the methods which we have already discussed in the last two examples, and then you can proceed as usual to find out its required integral. See, 1 upon t, t plus 1, 2t plus 1, this can be written as a constant upon first, a upon t plus b upon t plus 1 plus c upon 2t plus 1. Take the LCM of the left hand side as well as right hand side as we did in the example 1. You will get this equation, right? Now t, t plus 1, 2t plus 1, they are the factors. The roots are t is equals to 0, t is equals to minus 1 and t is equals to minus 1 upon 2. So putting t is equals to 0, t is equals to minus 1 and t is equals to minus 1 upon 2 in this equation, right? We will get the values of the constants. A is 1, B is 1 and C is 1, C is minus 4. Substitute all these values here. So this is the partial fraction and then you can integrate the given function as usual. So this is all about method 1, which simply says that if the factors are linear and distinct. Now let us take case 2. When denominator gx, take the second case. The factors are linear and repeated, right? Repeated means a factor is being repeated more than once. They are not distinct. If there are two numbers, they will be either same or distinct. So if a equation of degree 2 is having two factors, so both the factors are same. If I say x plus 2 square, this is what? X square plus 4x plus 4. So x plus 2 is a factor of this quadratic equation, but x plus 2 square means x plus 2, x plus 2. X plus 2 is being repeated twice. So this is the meaning of repeated factors, right? So if the factors are repeated, then the method or the process remains almost same, except a little bit calculation changes, a very little bit. Almost 90% procedure remains verbatim. Let us take an example. And what happens? See, 3x square plus 5x divided by x minus 1 and x plus 1 raised to the power 2. So see here, your numerator is 3x square plus 5x and your denominator is x minus 1 and x plus 1 power 2. See here, x minus 1 and x plus 1 power 2. So this is a linear factor, this is a linear factor, right? Clear? But x plus 1 raised to the power 2 means what? This is equals to x plus 1 and x plus 1. So this x plus 1 is being repeated twice, right? So the factors of the denominator are linear and repeated. Clear? Are you getting the difference between case 1 and case 2? In case 1, all the factors are distinct. But here, two factors which are being repeated, that is x plus 1. It is being repeated twice. So this is the case of an equation which contains repeated factors. So here, this x plus 1 raised to the power 2 is repeated, right? Since the factor x plus 1 square is repeated twice, so see what will happen here. X minus 1 is linear. So for a constant x minus 1, we have taken a upon x minus 1, right? No problem. But what happens with repeated? See, x plus 1 power 2 is being repeated twice, so what we will do? The factor is being repeated twice, so we need two constants. And if a factor is being repeated thrice, three times, so we need three constants. So what does it mean? It means how many times a factor is being repeated. We need the same number of constant. Clear? The factor is being repeated twice, so what we will do? We will need a constant a upon x plus 1 first, plus the second constant b upon x plus 1 power 2. Because a factor is being repeated twice, so we need two constants. For example, if we would have here power 3, x plus 1 raised to power 3, it means the factor is being repeated three times. So we need three constants. And how we write it? A constant a upon x plus 1 plus other constant b upon x plus 1 power 2 plus a constant c upon x plus 1 power 3. Right? You understand? So this is the only difference between approach 1 or method 1 and method 2, and the rest procedure is verbatim as we did in the last case. Right? So a upon this, b upon this, and c upon this. This is the partial fraction. Now find out the values of the constants a, b, and c. So this is the LCM of the left hand side, and we have taken the LCM at the right hand side. And after simplifying these LCMs, what we will get? We are getting as this equation 3x square plus 5x is equals to this. This is our equation, right? See, x minus 1 is the factor. So x minus 1 is equals to 0. This implies x is equals to 1, right? Put x is equals to 1 in equation number 1, you will get a constant. X plus 1 is also a factor. This is equals to 0. So this implies x is equals to minus 1. So if we put x is equals to minus 1, you will get other constant. So we have determined two constants, but we are having three constants. How we can determine the constant third? So the third constant can be determined by putting x is equals to 0 in the equation number 1. You will get the third constant, right? So after getting the values of a, b, and c, substitute all these values. A is coming out to be 2, c is 1, and b is 1. Substitute these values. This is the partial fraction of the given equation. Now integrate it. So the integral of the left hand side will be equals to integral of 2 upon x minus 1 plus 1 upon x plus 1 plus 1 upon x plus 1 square. And you know, the integral of 1 upon x minus 1 is log x minus 1. Integral of 1 upon x plus 1 is log x plus 1. And integral of 1 upon x plus 1 raised to the power 2 will be what? This can be written as x plus 1 raised to the power minus 2. So this will be what? X plus 1 raised to the power minus 2 plus 1 upon minus 2 plus 1 plus a constant. So what you will get? Minus 1 upon x plus 1. So minus 1 upon x plus 1 plus c. Right? So there is a very little bit difference between method 1 and method 2. In method 1, all the factors of the denominator are distinct. But in case 2, the factors are repeated. And there is a very difference in representation or in writing down the partial fraction, and the rest procedure for calculation of the constants a, b, and c remains the same. Now this is case 3. Case 3 means when the denominator contains non-repeated quadratic factors, right? Now this is a little bit difference rather than the remaining two cases. Although the approach is almost same. See, quadratic means any equation in which the power of x is 2. So any quadratic equation you know is of this type. Ax square plus bx plus c. Right? A, b, c are any constants. So what will happen? Case 3 is if the factors of the denominator are quadratic and distinct. And case 4 will be if the factors of denominator are quadratic and repeated. As two cases we have taken in linear, the same two cases we will consider for the quadratic. So the quadratic means if the power of the variable is 2, so for each quadratic factor, we need the constants like this ax plus b upon quadratic factor, right? This is how we write. What we did, in case of linear, we take a constant upon linear factor, right? But in case of quadratic, since the power of x is 2, we need two constants jointly. In this way, ax plus v upon the first quadratic factor. If equation is having two quadratic factors, so how we will write ax upon b first quadratic factor plus cx plus d upon second quadratic factor, right? And then you can find out the values of a, b, c and d as usual. Almost we will use the same approach. Let us take an example to understand the concept. The question is 2x plus 5 divided by x cube plus x square minus 4x minus 4. So here our denominator is an equation of degree 3, right? So find out the factors of this equation of degree 3. This is x cube minus plus x square minus 4x minus 4. If we take x square common, what is left? X plus 1 here, right? Take minus 4 common, x plus 1 here, right? This is equals to 0. So what you will get? X square minus 4 and x plus 1 is equals to 0. Now, they are the factors of this. See this, right? So here x plus 1 is a linear factor, right? Because the power of x is 1. But x square minus 4 is a quadratic factor because the power of the variable is 2. So what will happen? For a linear factor, we will use the old technique. A constant upon a linear plus x square minus 4 is the quadratic factor. So for this, what we will do? Ax plus b upon quadratic factor, right? Let us take this. 2x plus 5 divided by this. This is our original function. These are the factors of the denominator, x plus 1 and x square minus 1. So see here, x plus 1 is a linear factor. So we will write a constant a upon x plus 1 plus x square minus 4 is quadratic factor. So we will write it as bx plus c upon quadratic factor, right? Now find out the values of a, b and c. So as usual, take the LCM both hand side. What you will get? Our equation is coming out to be 2x plus 5. This is equals to x square a plus b plus x b plus c. Sorry. What is the equation we obtained after taking LCM? This is our equation. 2x plus 5 is equals to a x square minus 4 plus bx plus c multiplied by x minus 1. So see what will happen here. X minus x plus 1 is the factor, right? This is equals to 0. So this implies put x is equals to minus 1. If you put x is equals to minus 1 in this equation, you will get a constant, means this will become 0. You will get the constant a, right? One constant you can calculate this way as we did in the last two examples. But in this question, I would like to show you another approach, a new technique, which is also helpful. It is somehow calculative, but it will be helpful in all kinds of questions. See, this is 2x plus 5. This is equals to multiply this a inside this bracket. So ax square minus 4a multiply these two brackets. This is bx square minus bx plus cx minus c, right? Collect the terms of x square together, the terms of x together, and constant terms together, and see what happens. So we will get here 2x plus 5. This is equals to terms of x square, this and this. What we will get? A plus b, right? Then the terms of x. The terms of x are this and this, means c minus b plus, what are the constant terms? Constant terms are minus 4a plus c, right? This is minus and this is minus. Take minus outside. So what we will get? 4a plus c. Now what we will do? We will equate the like powers of x both sides. See, this equation we have obtained, right? See what is this? Cx plus c. Sorry. This is 1. So this is plus, right? So minus, we are getting, see, this equation is like this. We are getting 2x plus 5 a square, x square a plus b. With x, we are having b plus c, right? And for minus 4a plus c. I use here minus, that's why this calculation changes. So we can expand this equation by using this technique. Now after having this, we will compare the like powers of x both sides. So start from highest power. Highest power of x at the right hand side is 2. So what we will get? Coefficient of x power 2 here is a plus b. And at the left hand side, the coefficient of x square is 0. So first equation is a plus b. A plus b is equals to 0. Now compare the powers of x. The coefficient of x at the right hand side is b plus c. And this is equals to, the coefficient of x at the right hand side is 2. This is equation number 2. So b plus c is equals to 2. Third, the constant terms, that is minus 4a plus c. This is equals to, constant at the left hand side is 5. This is equation number 3. So minus 4a plus c is equals to 5. Now solve these three equations to find out the values of a, b, c, right? A number of methods are available to find out the solution of these three equations. If you have any problem, you can also put what is our first factor. Our first factor, that is linear, is given by x plus 1. So x plus 1 is 0. You will get x is minus 1. Put x is equals to minus 1 in this equation. See what will happen. If you will put x is equals to minus 1, so what will happen? X is equals to minus 1 means 2 into minus 1, that is minus 2 plus 5, right, is equals to a. Minus 1 means 1. 1 minus 4. And minus 1, this will be 0. So this is what? This is equals to 3. And this is equals to minus 3a. So from here, a is minus 1, right? See, this a is minus 1, a is minus 1. If a is 1, then a plus b is equals to 0. This implies b is equals to minus a is minus 1, so b is equals to 1. A is minus 1, b is 1. What is the value of c? From equation this, b plus c is equals to 2. C is equals to 2 minus c, b. So c is, b is what? What is the value of b? 2 minus 1, that is 1. C is also 1. So a is minus 1, b is 1, and c is 1. Substitute these values of a, b, and c. You will get this as a partial fraction. And now you can integrate it. Integral of this is equals to 1 upon x plus 1 with negative sign, plus integral of x plus 1 upon x square minus 4. And this is the same. X plus 1 upon x square minus 4 can be written in two parts. X upon x square minus 4 plus 1 upon x square minus 4, right? Minus 1 upon x plus 1 plus integral of x upon x square minus 4 is equals, can be written as this, and this can be written as this. So its integral, this is the integral of second, this is the integral of third, plus c is a constant. So this is how you can use the method of partial fraction if the factors are quadratic and distinct. Actually, case 4 is not for you people, because in that case, the case 4 is what? If the factors are quadratic and repeated. We will use the same technique as we used here in case 3, but when we will integrate those functions, their integral involves some trigonometric functions, and trigonometric functions are not the part of your syllabi. That's why I think it's not good for you to consider case 4. However, those who are interested, they can go through the case 4, but they can only find out the partial fraction of the given function. We cannot integrate it. As I have told you, the integral of such functions will involve trigonometric functions which are not the part of your syllabi. So with this, students, I would like to finish this here, and in the next lecture we will continue the next topic. Thank you very much.